Cool. 140, word break 2. Given a non-empty string S and a dictionary word containing a list of non-empty words, add spaces in S to construct a sentence where each word is a valid dictionary word. Return all such possible sentences. The same word in the dictionary may be used multiple times in the segmentation. You may assume the dictionary does not contain duplicate words. Okay. So I would say in theory, you could solve this with dynamic programming, and you should. But they don't tell you what the n is. So that's one of the first things I would notice. But that's mostly it. Maybe I would pre-calculate the edges and stuff like this. But I think in theory you should use dynamic programming. And if this just asked for the count, I would do it in dynamic programming. But the problem with this, or the hard part about this problem is that you actually have to return. You have to actually return all the sentences, which means that you don't gain anything by doing it with dynamic programming. And what I mean by that is that what I mean by that is what do I mean by that? What I mean by that is in dynamic programming, some of the, because no matter how fast your dynamic programming is, you still have to iterate it, and then in that sense, it is output sensitive, what your complexity would end up being, and that gets dominated by your backtracking as a result, right? Because or you have to reconstruct it even with dynamic programming with the backtracking. So I would just do this with a backtracking type thing. And the key thing to do there then is to kind of construct the graph in a way that so you don't reuse, or so that you can reuse some of the edges that you construct, so you don't keep on like comparing the same substring or something like that. I think for this part, I mean nowadays, or like I think the more recent problems, they do a better job of kind of letting you know the constraints of the problem, so you can at least plan it out a little bit. In this case, they definitely do not do this. So I will So I will whatchamacallit. So I would just make some reasonable assumptions, and then we'll see how that goes. Yeah, I mean, I feel like I got bitten by it sometimes, and then sometimes I ignore it, or sometimes I see other people ignore it, and I had to implement the things in a harder way. But yeah, I mean, I think for some of it is either on an interview. So if you do see this on an interview, there are two things. One is if they only ask you for the count, and you don't need to do the output of the sentences, then it's going to be dynamic programming, and from that is just the number of, well, there are two solutions technically speaking. One is dynamic programming, where you count the number of paths from the beginning vertex to the end vertex, which you can actually solve in a different way, because the number of paths from A to B is also, if you take the what's it called, the adjacency matrix, and then you could do some fancy math to kind of calculate the number of paths from the beginning to the end. So it ends up being like like n technically like the sum of the first. So let's say A is the adjacency matrix, then you want the sum of A plus A to the A squared to dot 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 to all the way to A to the n, which is a geometric sequence that you could kind of do maths with. But that's probably way too complicated on that part. But yeah, okay. Anyway, all that said, I'm gonna make some reasonable assumptions about it thing in n, and then I'm gonna do backtracking. And then but before that, I'm going to construct the adjacency matrix to kind of cache some of the dictionary in that way. And because the dictionary, an observation that I would make is that between two nodes, and by two nodes I mean the space between two indices. So you have a node between each indices, for example, and then between two nodes, there's only one word in the dictionary that could fit in this case because it has to match, right? So in some cases there may be multiple edges and you have to be careful about it. Different type of problems. But for this problem, there's only one possible edge that could be. It's either there's an edge or there's no edge, right? And this would kind of allow you to do that. And there's some optimizations that you can make with rolling hash and stuff like this, and we will get into it. Yeah. So there are definitely a lot of optimization, but the core part will be maybe the optimization is the core part. Well, we'll see. But yeah, so this n an assumption from 0 to n. So there's actually how do I construct? Yeah, okay. So now let's just, I have a G, which is a graph. Let me just, okay, fine, I just label it. And then just say force times n for okay, so this is just a graph, nothing, there's no what you call it. And then now we want to construct the edges. So so you could do it in a couple of ways, but for us to take advantage of, say, something like, I don't know if that is a premature optimization, but so the naive way of doing this is kind of like, okay, for the prefix, okay, for I in range n, if well, now for word in word dict, if f, so if the word is the function starts with, no, but no, we want the whole word though, right? Equals word, which we need is I plus word or length of word. We should cache that actually, because this becomes expensive after we do it a little bit. I think maybe I actually don't know the implementation detail in Python, so maybe it's cached. So maybe I'm just wrong on the slice size. In some languages, like in C, that would you need to go for the string to count the word. So maybe I don't need to make the optimization. But anyway, so if that's the case, we want to put is equal to true, right? But we have to make sure that I plus line of word is less than n. Maybe less than equal to? Well, we'll see. That's kind of the way I would do it. But in theory, if you just change the for loops, now you could actually, instead of using this, you could do a rolling hash, which maybe I'll do later if this still times out. But that's what I will kind of play with that for now. Yeah, I mean, I guess I could use starts with. I think this actually is more precise in the sense that I don't know. I mean, I think it's the same probably, but I think this allows me to be, because maybe not, because I end up doing this anyway. But yeah, also this graph part as well. But okay, so now let's actually, let's do a check-in and see whether this gives us what we want by printing the array or matrix. Okay, well, okay, maybe we don't want the entire graph. Maybe that was a little hard. But in the meanwhile, while it's loading, I'm going to put in a test case. Parallel work, Okay. So 0 to 3 is cat, 0 to 4 is cat, 4 to 7 is n, and 3 to 7 is sen. Clearly there's an off by 1 because the dog is in there. So that's why I wanted to double check. Oh, does it? Okay. Yeah, I just wasn't super sure, to be honest. I'm always just bad, like, for example, like this, right? So I actually was thinking about this while doing it, but because if you think about um, because if you think about it, a node being the space between the characters, then there should be one in the beginning or onto the end. So there should be plus 1 edges. Okay, so this is good. So yeah, dog is in there. That's the thing that we wanted to make sure, and or at least for me. So some of what I would say is that know your when you know your weaknesses, then you could kind of figure out what to debug from. And then in interview, obviously, this is a little trickier in the sense that especially if you're on a whiteboard, like, well, that's not really an option. You can't really want to debug it on a whiteboard, but at least you could talk your way out of it a little bit better on a whiteboard because, well, you know. Okay, so now the graph is constructed and it looks okay. So now we can just do we have to sort anyway? Or the return sentences? Do we have to kind of just looking at the thing? Looking at the input, I guess it doesn't say on the input what how like in what order do we need to return this. In this case, even it's not even sorted, so maybe it's okay to not sort. So okay, but if it costs me a wrong answer, then it is what it is. But so now this is just now it becomes just a recursion, right? If yeah, I could search it. Yeah, so I do something like this. Okay, let me actually label these things. Um, so now, and then we just want to, so you could do this carrying, like returning a result that you carry through, but I would like to just return um, like a global variable, just for kind of, it's a slight optimization for that reason, because I don't want to, yeah, mostly because I don't want to, whatchamacallit, but it should be okay. I'm missing something, obviously. Sorry, I'm thinking about something else for a second. Yeah, but it's a little bit of optimization so you don't keep on passing the reference around, but I think maybe that's okay. Uh, yeah, okay, maybe let me try to do it that way. I think in some languages it's less performant. I think in Python it's probably okay. So let's just return the result and then the running string. So now your depth of search is kind of the tape, what I could call it. Let's just call it results, and then the current string or the running string, if you want to call it that. Oh, this is start from the first index, obviously. Or you can also go backwards, but I mean on this problem it's easier to go forward. Yeah, and then now I think actually, I mean we have an adjacency, what we call it, matrix. Now that I understand the problem a little bit better, actually we don't even need an adjacency matrix. We could do an adjacency list, right? So then our for loop here, I mean, I'm thinking a little bit ahead before I type the code, but my idea would have been like, okay, well now we're on index, and what I would have been done is like, okay, for x in range of n plus 1 actually. We were like, okay, if graph is index to x, recurse and do work or something like that, right? And this means if there's an edge from index to x, I mean, I probably would rename this a little bit better, but if you notice this here, then this is always going to do all of n work. But we change this to an adjacency list, then you only do the number of work that's on the edges, and that kind of allows, that just is a speed up, and it's actually maybe not insignificant. So that's why I'm kind of doing this now. It's a relatively easy thing to do. And then here, and because actually these end up all being DAGs, or I mean, it could be directed edges, but it doesn't have to be. It's just that you would still go only in one direction, so it doesn't really matter how you model it in that regard. But I would have something like, okay, f sub I is append to I plus length of word. So that means there's an edge from I to I plus length of word, and I get rid of this. And yeah, and then now instead of this thing, I could do for v in graphs of index. Maybe graph is a little confusing a word, but and then now, well, of course, there's a v is by definition an edge. So now we just have to, we don't even have to do the if, and it's slowly faster. And then now we can just do it this way because we don't have to check anymore. And then we just want DFS results. Do I want to do it this way? No, I think I'm just going to leave the results out of it because I'm constructing this in a weird way in general. But and then now we want to add the current word, which is, oh, I guess I should have put this in the word text. No, I mean, you could figure it out because it's just, what you call it, S from index, yeah, maybe v minus 1, but something like that. Okay, and then it's just, and you want that to be the, and something like that, right? Now that's pretty much most of your code except your base case, and your base case as well, if index is equal to n plus 1, just return, well, put in the results, something like that. Woof. I have to call this non-local, I think. Maybe. No, I think you don't need it to do it when it's set. But, well, that's interesting. Gong, gong, gong. All right. Oh, this only ever goes to n, so maybe this should be n. Maybe I'm thinking about something else. Okay, there we go. For some reason, I have to think about my state. Oh, because the n plus 1 number of states, but the last state is n. Okay, yeah, I won in my head. But yeah, but let's see. Is my answers right? I guess so. Okay, well, this one had a weird prefix. Why do I have a... why do I start with an extra thing? Oh, because I do this way. I meant left strip. Whoops. Because you never get it at the bottom. You always get in the beginning. Okay, and then now... Well, let's see if it passes running time. That's my only concern. But in theory, like we could do an optimization here. But I think beyond that, ooh. Huh, really? Yeah, the time limit exceed is the only thing, but I don't even know if oh, it won't tell me the thingy. Okay, well, let's just comment this out. I just want to see what the expected result is, in the sense that this is like exponential in theory, or did I miss something? Expected as, do I only do each? No, each word can be used multiple times. Oops, where's my oh, there's a B in the middle. Whoops, I missed the B in the middle. Okay. Okay, so there is. I mean, I think the tricky thing with these things is that, I mean, okay, because what I want to say with problems like this is like, in the general case, it's still going to be the same, and it's just about kind of what kind of optimizations you do. And this is kind of like a weird optimization of like, okay, well, if it's not reach, and in some weird ways, like if you're given all the inputs, then well, yeah, you can like not like you wouldn't hard code the answer per se, but you would able to do optimizations that make sense for your input set. And in the real world, if you do backtracking, that is really important, right? Like you want to tune your algorithm and your backtracking and your branching to fit the data that you're given. And in this case, for example, like if I knew that unreachable is going to be a big case because then you would just have a very easy filter to it, right? But um, but yeah, so and if you add like a very minimal like a for loop check, which I will do now, I suppose, it would save a lot of time on something like this. But like let's say in a parallel universe where you even get rid of this second half. I didn't notice the B before this. I didn't see it. But let's say you get rid like okay, let me put this up on the thingy here. Let's say that's the input. Like let's say we just use this, right? Well, what is the answer? The answer is still that it's time limit exceeded, and there's no way that their answer is going to pass. Like we could even test that out, right? Okay, maybe because this is exponential in nature, right? Yeah. So wait, did I miss something? How come we didn't even put? Yeah. So I think the answer is that they don't even have an answer for this, right? So I guess what I'm trying to say, and some of that is like I'm a little bit annoyed in the sense that some of these problems become a little bit of a guess what the interviewer is doing or guess the problem right and what they're doing, because like in this case, like the 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 intended solution cannot pass this because it's exponential in nature. And you could it's actually there's a fun and like I was mentioning earlier with dynamic programming is that there's actually this particular you could actually do the math on how many well you could use dynamic programming to count how many solutions there are to this solution or to this input. That's one. But two is actually this particular input has a really underlying similarity with the Fibonacci sequence. And maybe for your own time, because you can think about maybe this is an exercise for homeland. It's just something that I'm nerding out on a little bit. But like if you think about this, and let's say these are your input, then this is actually ends up being just a Fibonacci sequence, and you can prove to yourself why. And then so if you think about it that way, then this is just a little bit of an extension of that, and so forth, all the way to like all these other stuff. And these are things that you kind of notice when you do a lot of problems. But anyway, my most of my rant is that like okay, look, is it helpful to have a filter that this solution forces you to have? Yes, it's helpful. Would you kind of like it's like well, would you know ahead of time before someone's like, okay, this is the wrong answer? I'm like, well, I mean, I would say like on an interview, then people might ask you like, okay, like like I'll be like, okay, this works in a general case, and then your interviewers might be maybe like, hey, like what if there's this case? How would you optimize for that? I'm like, okay, but in the long term, or like it still takes a lot of case, but we could optimize for certain cases, like the unreachable case, by adding like a couple of lines of code and be like, okay, and this cuts off some computational time, but like that's still not going to be generally correct because even a shorter string that like I was saying, okay, now I'm like a little bit annoyed, but that's the general idea, and that's why I didn't really test for that because I feel like the complexity is still the same. It's just you just deal with different edge cases and without knowing without them describing it or whatever, like it just becomes mind reading, which sometimes you get lucky and you do, and sometimes you don't, and you're like, well, I should have known, I guess, but like I didn't know you were gonna ask me on it. But yeah, so okay, so in this case, let's do because basically the algorithm we have, it's gonna be relatively output sensitive, uh, except for the one case where it's unreachable. So like, and when you're output sensitive, what that means is that you can't really do better than that because you cannot do better than O of one for each element that you're outputting, right? So in theory, it is optimal if you analyze the complexity in terms of the output. That's what I want to say. But I guess there is one case where that's not the case necessary, which is that if it's unreachable, and you could kind of do this reachable thing in a few ways. Um, Also, it depends what the n is, because now I'm trying to figure out if I just want to use like because for reachability you can maybe do like Warshaw algorithm or just like a breadth first search. I'm just going to do breadth first search. So it ends up being both. But yeah, okay. Well, let's actually do this after we construct the graph because that makes it easier. So now let's just start. So you could do this with breadth first search. Let's just say, I guess we just need a set. We don't really need the distance. We just want to calculate reachability, and then and just start with 0. Oops. And well, I know that you can also, I know that you can do something like this, but I feel like this is slightly more readable. So I always do it this way, even though I know that the other thing is a truth value. Um, but yeah, okay. And then now, oh, actually, I always forget. I mean, I always remember, but afterwards, but I always forget in the moment. And the reason for that is because you want to pop, and a list popping is not whatever. I mean, I know you could have done it some other ways, like within, but I like to just use a deck. Um, Now is equal to q dot pop pop left. That's right. Yeah. Though it doesn't really matter which way you pop because was in this case it's just reachability, right? And you're popping that, it just ends up being depth first search as long as you don't visit the same set or same nodes. It's probably fine. Okay, so now for v in nope, the graph from now to v. Oh nope, that's it. If v is not in the set, then we want to put it on the we want to put it in the queue and then also put it in the set. The autocomplete annoys me actually. Anyway, and then now if now is equal to n, then return true for reachability, and then return false if not. And then now we could just be like, okay, if we have s, then return empty array. Okay. I guess now we don't need this case to prove my point. So let's delete it and then test again. Oh, really? Maybe I have some weirdness. No, the string comparison shouldn't be that slow, right? I mean, I guess this returns false. Oh, I'm just dumb. Sorry. This should be the other one. There you go. And because I didn't test the other ones, yeah. And also maybe now, maybe I should rename this to be, then that would have been more obvious that I wanted the right thing. But okay. Yes, and then now I'm still confident-ish, but I was confident-ish last time, so let's submit it again. Okay, cool. I mean, still not super fast, but that's fine. Yeah, I mean, I think I already rant about it for 10 minutes, how I don't like that. This is the reason why I get time exceeded. But it's okay, I guess. It's just that in an interview, these are part of the back and forth that you have with your interviewer, and you would kind of talk about it. So I think it's not that bad as a thing that's in an interview. And on an interview, your first instinct, or your first thing that you should do in general, is to make sure that you get something up and running, even if it's not performing necessarily. In this case, I'll be like, okay, so this, I would talk about what I mentioned, which is that, like, okay, this is backtracking, this is output sensitive, so it's optimal because even if like your running time will be dominated by the output sensitive part, and there's potentially an exponential whatchamacallit. And there actually, now that I think about it, there's some optimization that you can make. Like if you go to an index that is not, there's no, like you could do a reachable, do the this, you could do this reachability graph backwards from the end node to the forward, and then if you go to an index that is not reachable from the end, then you just return early so that you actually get even a faster optimization. But so there are definitely optimizations that you can do, and these are things that if you're in an interview and you get into a backtracking problem, which is something that we talk about, then these are things that you talk about in general. But I would start by explaining why, and then get some implementation out, and then make optimization as you feel is necessary. And also, when the interviewer points out some optimization that you can make, because in the general case, like it depends on like your input data in the real world anyway when it comes to backtracking, and then you could figure out what you really want to do with it. Um, yeah, and for that reason, I think in general, nowadays, I feel like on the competitive programming part, uh, people are better about limiting, setting the constraints in a way that it is transparent. What are the tricky cases? Like this case would, oh, yeah, this case would never be an, well, I wouldn't say never, but it would not be in a good problem setter's input, because like there's no reason why this should pass, but a shorter string would fail, right? With the time limit exceeded. So there's like some weirdness there, and but yeah, but I think that's what I have for this problem. Otherwise, it's pretty straightforward, right? Like I mean, I think the so there are a couple of optimizations that we could have done. One is what I just talked about doing the reachability backwards from n to 0, and then when you go forward, um, if you go forward, then you could eliminate those early, which is actually something similar to reach in the middle, which I think some people mentioned before on stream. Another thing that you could have done here is noting that this this function, you could optimize by using a rolling hash, because this is technically n squared, because or not n, well, I mean it could be n squared, but like n times some k, for k is equal to the length of the word. But if you use rolling hash, then it's just O of n, so you cut away the length of the word as the a constant factor, or like just a factor, that multiplicative factor in the optimization, which sometimes comes in handy. But yeah, that's all I have for this problem though. Overall, I mean, an okay problem. I don't feel bad about it. It's a little bit annoying to kind of get a wrong answer on this, but it is what it is. It's okay. Just here to learn, not to flex on this. So it annoys me a little bit, I guess.